Welcome to this session, Infuse AI into your web applications -AI and JavaScript. Was not the session title I wanted. I wanted AI JavaScript rocks, but people didn't seem to think that would resonate with the audience. Would that have been better? Yeah, good. So my name's Asim Hussain. You can find me on Twitter at JawAche, not Jawashe, JawAche. I blog about Angular and JavaScript on my website, codecraft.tv. And I'm also what's called a cloud developer advocate at Microsoft. So we're a fairly new team inside Microsoft. We are the open source advocates. There's about 60 of us right now. There's about 10 or 15 of us at Ignite right now. So if you go to the link there, you'll find a list of all of us. We are the open source advocates. So my area of specialty is JavaScript. We chose the word advocate very, very specifically because it's a two-way street with us. So we roll up directly into the engineering organization. So both I talk to developers all over the world, and I advocate Azure to developers. But at the same time, I also advocate kind of web and JavaScript technologies back to the product team. So if you've got any feedback, anything about web or JavaScript on Azure, come speak to me. You can DM me on Twitter, and I've got like a straight line back into the PM orgs. So there you go. I'm also an instructor on the platform Udemy. Does anybody know Udemy here? Any of you my students on Udemy? Hey. So I'm an instructor on Udemy, and recently they added in automatic subtitling, and they correctly transcribe my name to, whatever, Awesome. Awesome. So my name is Awesome. I tried changing my handle to that at work for a while. I lasted about 2 weeks before my boss said change it back. But I really liked when somebody wanted to contact me, they had to do @awesome. And this is kind of me, right? So this is a slide. This is my friend's slide, Eleanor. So kind of like into web development, here's me and machine learning. I've always been interested in machine learning for a long time. I used to be a Python developer before a web developer, and I used to do a lot of machine learning stuff down there. Not mine. Eleanor's slide, right? So me and Eleanor, we're friends. We go back a long way. And we were out hiking kind of earlier on this year. And a lot of interesting stuff's been going on with AI and JavaScript just from the start of this year. And so we said, you know what, let's make a meetup group. Let's just start kind of talking about this stuff with other JavaScript developers in London. And we created, it's called AI JavaScript London. And that was really good. We've only been running for about 6 months, but the demand has been incredible in London. I think we're one of the fastest growing meetup groups in London. And then what would happen in our meetups is people would then send us links to demos, the kind of AI-inspired JavaScript demos or little apps out there. And so we thought, well, why don't we put this on a website to kind of celebrate AI and JavaScript? And that's actually what we did. So we launched it earlier on, kind of a month or two ago. It's called AI.js Rocks. So it's available right now. You can go visit it. And what it is it's basically just an inspirational collection of, what did I write? Or whatever. Inspirational collection of AI JavaScript. Oh, it's a better tagline than that. I can't remember it. But yeah, there it is. And when you go to the website, you're just going to find us, a curated collection of inspirational AI-powered JavaScript applications. So it's a whole bunch of different JavaScript-powered, AI-powered JavaScript applications. What we wanted to have with the site is a place where you can learn as well as just be inspired. So each and every one of these applications has a link, so you can actually go and try out the application in the browser. It's all JavaScript-based, right? So you can always run it somewhere. But at the same time, we also wanted it to be a place where you could learn. So each example has at least a link to the source code, so you can browse the source code, see how it was built, or a link to some more information about the application to find out more details about it. But the goal for the website is a place where you can go and just be inspired and then go learn, okay? And so what we're going to go through today is just going to whiz through a bunch of demos from the site. And one that's not on the site, but it's mine. But I'm going to whiz through a bunch of different AI-powered JavaScript applications. And I'm going to teach you, I'm going to show you what it does. And I hope I'm going to show you how it does it. And as we go through the different applications, by the end, you're going to learn a lot more about different ways in which you can do AI in JavaScript. Okay? Right. First application. Botus. Okay? So Botus is, it's basically, has anybody listened to the Planet Money podcast? Anybody? Do you know Botus? Okay. So Botus is an application they made kind of late last year where they discovered that if Trump tweeted something positive about a company, the stock price would go up. And if he tweeted something negative about a company, the stock price would go down. So they then thought, well, wouldn't it be cool if we built a trading bot which can make trades based on those tweets? And that's exactly what they did. And released on Twitter as Botus. So if you go into Botus and you can follow this account, and when he tweets something positive, you will see what kind of trades it made. Well, you would have been able to, but they in fact shut it down late last year because they are a podcast and not an investment firm, which is why I decided to make my own Botus. I've never made any money through investments apart from one accidentally once when I forgot I bought some gold. So the rules of Botus are pretty simple. If it's a positive tweet, it buys $100. Oh, it's an FX trading engine. If it's a positive tweet, it buys $100 of the currency. So if it's a positive tweet about the UK, it'll buy $100 worth of pound sterling. If it's a negative tweet, it sells all of the currency. And if it's a USD, then it inversely buys and sells gold, right? But the key thing here, that the app is actually really complex. I talk about different parts of it. But the key part of it is here. So you've got this part of the application, a Twitter feed. And you can see here, it's got a tweet. It's got a green thing at the bottom with a number in it. That is actually the sentiment score for this tweet. Probably not a sentiment, that's the actual tweet itself, but the meaning behind the tweet. So here's another tweet. Scores very, very low. And therefore, it's described as a negative tweet, okay, emotionally negative. So the question here is kind of how do you figure out if something's positive or negative, right? So you do that with something called sentiment analysis, which is quite a common pattern these days. So how you do it is you basically get a bunch of data. So you're going to grab a bunch of text strings. I love you, I hate you, no way I love that, this is rubbish, let's meet at 10 p.m. But then the key thing is you have to label that data, okay? Somebody, a human being, usually needs to go away and actually tag each one of these as positive and negative. And you actually need quite a few human beings involved as well, because the same sentence to one person can be positive and to another person can be negative, right? There's subjectiveness here as well. But essentially, there's a lot more that goes on here as well, but essentially, you get that training data, you pump it into a classifier, and there's many different types of classifiers out there, and it learns and trains, and at the end of the day, it generates a model, okay? So the model is static. The model is whatever it can be. It can be a series of weights or just a long mathematical equation, but essentially it's just a static set of data, okay? And the important thing about AI is that we trained it on one set of data, but then we can give it something it's never seen before and have it try and infer whether or not it's a positive or negative tweet. And that's the power of AI, right? You can train on one set of data, but then you can give it different problems from the same domain, and it can then give you different answers, right? So there's lots of different ways. So normally what you would do is you'd basically get this model, and again, it's usually quite static. You can get it, and you can download it and put it on your device or on your computer and kind of use it that way. But quite a common way we would use it is we'd get that model, we'd export it, we'd put it on a server somewhere, and then we'd wrap it in some sort of web framework, and we'd basically make some API requests to it, right? Maybe we'd pass it hello, and it would turn us back some JSON about the sentiment of the text, right? Yeah, that's what you do. In fact, that's what we do in Azure. We actually create it. It's called the Text Analytics API. And what it is part of a suite of services we have in Azure called the Azure Cognitive Services. Now, this act of taking well-known problems, crunching the model that represents it, and then wrapping it in an API and making it available to people via services is a really common pattern these days. This has been one of the biggest growths in the AI area I've seen in the last 2 years. Many, many people are starting to build these kind of services and release them. I think we've got one of the best set of services out there. Very useful, very broad, okay? And it's quite simple. You just make an API request, and this is it. So the actual API for text analytics returns a couple of other things. So it actually returns the key phrases of the text as well. So it extracts out from the text kind of key terms, which is very useful when you want to figure out if a tweet is about Mexico. And also the sentiment as well. Why is this not working? Also the sentiment score as well. And a few other things as well, right? So that's a text analytics API. And what I'd say when you're facing a problem that you think might be able to solve with AI, first, for common problems, search for APIs. Sentiment analysis is so common. It's been very well documented for 30 years. There's so many models out there. Just search for an API search for a pre-built model. There are use cases when you will need to actually train your own models. For instance, when you're dealing with uncommon domains of text. So for instance, if you're dealing with kind of deep academic texts in a particular medical field, the text and terminology might be a little bit different. Maybe you would want to train your own sentiment analysis using that body of data. But if it's just general, search for an API. All right. Voice calculator. This is another demo on AI.js Rocks by my colleague Brian Holt. Hopefully, the sound will work. We'll see.
Add 5, multiply 3, subtract 2.
Okay, so it's a pretty simple demo. You can actually go to, it's just a code pen. You can go and try it out. And it's actually just a voice-powered calculator, okay? Now, it's doing two things. First off, it's converting voice to text. And it's actually, in fact, we have an API for that. But it's actually using the browser-based web speech-to-text API to do that. But then to understand the text and perform calculator commands, it's actually using another one of our services, which is the Lewis APIs. Does anybody use Lewis here? Okay, quite a few people. Well, not quite a few. 4. I have a problem with exaggerating. But yeah, so you can just visit it, lewis.ai. I think it's one of the easiest to use APIs that we have. And in fact, my colleague Burke Holland wrote an article for Smashing Magazine a few months ago now, actually, which kind of details because it's a great introduction, actually, to Lewis AI. I'd recommend having a look at that. And he used it to build a chatbot to control the lights of his house, okay? So how it works is you basically, you get these kind of examples, just as I described before with sentiment analysis, you do need examples of text. So you get examples, and they're actually termed utterances in here. So each one of these is an utterance. Such a British word. I always find it strange here. Utterance. So you have these utterances, and then you have to tag them yourself. So the same way before I showed you had to have the text, you have to tag them manually. You have to grab the utterances, and you have to tag it. So you tag the words there that signal the power. And then then you can also tag the location as well. And then once it's all tagged, you then can just train it. And this is doing the same thing as before, where it's learning to understand the natural language, the natural human language. And then the whole thing is then available to you via an API, right? So if you sent it, turn off the garage lights, it's then going to know that your intent is to control lights, and it's also going to return to you the value off for power and the value garage for location. So human language is extremely imprecise. But when we write computer programs, we need things to be precise, okay? Lewis is the thing that helps you solve that problem. If you don't really want to use an API to solve some of these problems, there are other JavaScript client-only based libraries. This is one that came out very, very recently called NLP.js. There are a couple of others as well, but I think this is very good for chatbots. This, again, is it's a JavaScript library, so it's running on the client side. So you don't need to make an API. Well, it does look like it's making an API request. It's making a local API request to a local server because it's a chat window. but this just lets you run it locally. Now, it's not going to give you as much accuracy and as much customization as something like Lewis AI, but it will give you something that you can run on the client side if that's what you need. So to summarize, I really love kind of Lewis AI and kind of chatbots because they're a great way to get into AI because we all want to kind of dip our toes into it and start moving into it slowly. Okay? You do start to think about certain ideas, like you have to think about utterances, you have to think about tagging, you have to understand about training. So it starts dipping your toes into it, but a lot of other things are handled for you by wrapping things up in APIs and allows you to build pretty advanced stuff very, very quickly. But it does help you start getting into the space. So yeah, try Lewis AI or NLP.js, or just search for some of the other ones. I do recommend that as a good start. One of my favorites, the Emojifier. It's not trademarked. TM stands for the Emojifier, so thought it was worked. But the Emojifier is a world-changing application. It's going to change everything. So with the Emojifier, what you can do is you can pass an image, and any guesses? Shout it. Well, he has to have the prize there. Yes, it emojifies it. So basically, it figures out where your face is in an image, number one. Figures out the emotion on your face. Ooh. And then figures out the correct emoji that matches that emotion. And then puts it on your face. Right? That's what it does, the Emojifier. I originally wrote it as a Twitter bot, which I'm going to explain to you why that didn't quite work out as I planned. But I originally wrote it as a Twitter bot. So in fact, it may still work right now. But if you go onto Twitter and you reply to any tweet with hashtag Mojify, it will then go away, figure out the emotions, replace them all with emojis, and post them back onto Twitter. Well, I would say it doesn't quite do that because of perhaps maybe or may not be some actions of certain countries with fake bots. Twitter have kind of cracked down really, really hard on kind of any automated Twitter bots, and mine got shadow banned twice. Has anybody heard of being shadow banned? Has anybody been shadow banned? It is the most weirdest thing in the world. A shadow ban is when you get banned, but nobody tells you and everything still keeps working. The only thing is that nobody can see your tweets. Okay? Can you imagine being a developer debugging this, and you're like, whoa, the function ended correctly, the tweet is posted, I can see the tweet, but no one's liking it. Yeah, it's because no one else can see the tweet. So I got shadow banned twice, which is why I've actually rewritten this as a Slack bot. And I'll give you links to that later on. But I think the key thing here, and the thing that people were a bit ooh about, was the calculating emotion. Okay? And how do you actually go about calculating emotion? And I think to understand that, this is where I start talking about neural networks. Anybody here has experience with neural networks? Building neural networks? 5. Excellent. I'm talking to everybody else right now. So what is a neural network? Okay, a neural network is based upon real biological aspects, so based on a biological neuron. So this is one neuron in your brain. It has dendrites that flow in. So electricity flows in through these, and if enough electricity flows in, it fires electricity out to the axons. So if you put, can't remember how many, billions of these in your head, then you form a brain. I personally think there's a little bit more to consciousness than just the brain, but you do form a brain, and a brain can do quite a lot of intelligent things. But the thing is, you can actually create one of these artificially. Like if you think about it, it's not that complicated, right? If you're programmers, they probably did this at university. It's just a node with some edges going in. Remembering Computer Science 101 or something, right? Edges going in. And then what we do is we pump values into these inputs. And each of these inputs has, each of these edges has weights, okay? So these inputs might be different things. So it might be, I don't know, house price times number of Kentucky Fried Chickens or something like that in your area. There was a study done in the UK about this. And then we have the weights, and then basically it pumps it through something called an activation function. If you can remember the body, it was only going to pump out electricity if enough electricity came in. And the activation function is a thing that decides that, okay? And it pumps some value back out again. And if you connect enough of these together, you essentially get a neural network, right? So look at the screen. Animations. This is it. This is all the mathematics that's happening inside this neural network, is you get the input values, you multiply them by the weights, you add them together, you pump them through this activation function, and it outputs a number. And then that goes as an input into another one, an input into another one, and an input into another one. This is a perception, the most basic part of a neural network. The activation functions, you can have different ones. This is a very, very simple one. As you can imagine, values just below 0 is 0, just over 0 is 1. Very easy to calculate, but it has a problem in that small values have big jumps. So we've got hyperbolic tan, which is another one, which gives you more of a gradient. We've got this other one called rectivated linear unit. There's other different types of activation functions out there, right? But essentially, all you're doing is with a neural network, all you're doing is getting those very, very small building blocks and connecting them all together. It's a very, very simple neural network. One input layer, one output layer, two hidden layers, and they're just all connected together. What you do is when you create one of these, you initialize each of those edges with a random value, just a random value. And then you get one item from your training data. If it's emotion, maybe what we're getting is maybe we've pre-processed it through some computer vision library and grabbed the various points on a face. You know, there's various landmarks, famous landmarks on a face. Maybe those are the inputs to our neural network. And the output, maybe 0 is unhappy and 10 is very happy. Okay, that's what we want out of this. So we feed in those landmarks, and then essentially just does that multiplication. All that neural network at the end of the day is just lots of matrix multiplication, right? Does that multiplication and outputs a number. So it thinks that my face is very unhappy. But what if I knew that I was actually pretty happy, right? If I knew I was pretty happy, I would know that the neural network is off by 5. And the magic of a neural network, not the magic, probably the more complex part of a neural network is how do you change these biases so that when you pump the same data, it comes out with 8. You need to change them. And that process is called backpropagation, okay? And that's what you're doing, is you backpropagate. There's an error of -5, so you need to adjust the weight somehow, so the next time you go through, it's going to give you 8 again. It's backpropagation. And so yeah, maybe the weights through that training change to this, and maybe then when you pass in the same data, it gives you the right emotion. And then when you give it new faces, it's going to accurately predict the emotion of the new faces. Okay. Now you could do it that way. Any guesses what I'm going to suggest as an alternative? No? Oh, okay. Azure Face API. I always think it's a very unfortunate picture we have in the cognitive services. On all of them, it's the same person. It just looks really confused. I feel there should be a face of somebody who understands what's going on. But it's like, what is this? So we have a face API. It does a lot more than just emotion. But emotion is, I think, the funnest thing it does. It also has real value to it as well. But it's, again, just as easy as anything else. You just basically post an image. You can post a path to an image, or you can post binary data itself over to the API, and it will turn you a whole bunch of data. This is just a subset of the data it would send you, but essentially send you an array, one for each face, the actual rectangles, which are important for placing emojis. Remember, this is about the world-altering app of the Emojifier. So we need the rectangle of the faces, and I need to know, and it gives you an object giving anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. A little bit of a fact, if you have a beard, you cannot be 100% happy according to the Face API. I've tried, it's impossible. I can get to 99.99, but I can never get to 100, which is sad in a way. But yeah, and it returns a whole bunch of other data as well. Like if you want to get the exact locations of various landmarks, it will return you that as well. So, summarize. What I just really want to get across is that neural networks are really, really powerful. And a lot of the APIs that we have been built internally using neural networks, okay? Trained up internally using neural networks. At least I think, because we're not told, because it's proprietary. But from all accounts, it's built using neural networks. And the other thing I wanted to get across is that conceptually, they're actually quite simple. I think they're quite simple to understand, at least the basic case here. I explained the basic case to you in like 5 minutes, right? There's far, far, far more complex examples, but the basic understanding you can get pretty quickly. Oh, wow. OK, next one. TensorFlow, MobileNet, and I'm Fine is a weird title for a demo. But we were at Build this year, and our team's T-shirts were, we had like a puppy stand. I don't know if you know. But in Build, we had a puppy stand where you could go and pet animals whilst you're walking around. And so we had T-shirts called Azure, Puppies, and I'm Fine. So I ran a workshop in London, an AI workshop in London a couple of months ago, and I was wearing that T-shirt. And so one of the attendees, Oliver Turner, then basically made a demo based off of what he learned in that workshop, and he called it this name. It's quite simple. So it's against a code pen. And what it does is you can pass it images, and it'll actually try and guess what's in the image, right? So here, unfortunately, it's a small child, and it says miniskirt, whatever. Sand, sandbar, seashore. So it's kind of fairly OK in this one. Other ones, if you do search for puppies, so it's actually doing an API request to Unsplash and getting that. For some reason, puppies returns, it's not even a fur coat, to be honest with you. And if you search for I'm Fine, I can't remember what it gives you, actually. Oh, yeah. Platypus, duckbill platypus, paddle boat. OK, probably not the best one, that one. Let's do Azure again. Fountain, haywing. OK, whatever. It's probably not doing that great a job at this point. OK. But sometimes it does an OK job. Most of the time, it does a pretty bad job. But the important thing to realize about this particular demo is that this is all running in JavaScript in the browser. Okay? The only API request this is making is to Unsplash to get an image. The actual guessing of what's in the image is happening inside browser using a framework called MobileNet. Okay? And how is that happening? Well, it's using a tool called TensorFlow. Does anybody use TensorFlow here? Every time I ask these questions, it's a different set of 4 people. So I think the set of 4 people who know TensorFlow are not the set of 4 people who know neural networks, which is, did you put your hand up for neural networks? OK, maybe I'm wrong then. So yeah, TensorFlow. So TensorFlow is it's a tool that allows you to train machine learning models, and especially useful for neural networks. It was released by Google. It was used internally in Google for a long time, I think. Then it was released and open sourced in about 2015. And it's written in C. It's very well optimized to run parallel computations across a GPU, across hundreds of CPUs. It's for doing vast mathematical calculations on hundreds and hundreds of servers, right? But it's written in C, and most people use Python to interact with it, right? But the really interesting thing is, about 6 months ago, and I don't even think it's 6 months, I think it's maybe 5 months ago, they released TensorFlow JS. Oh, yes. And I think at the start when I heard about this, I was like, OK, whatever. It's just bindings for the TensorFlow that you've got installed on your computer, right? And it's not. It's not bindings. It's TensorFlow completely rewritten from scratch in JavaScript. Okay? Completely rewritten in scratch from JavaScript. Why is that cool? Why is that important? I think it's cool because of this, right? So now, in order to use TensorFlow, in order to build neural networks in your browser, in JavaScript, you just need to do this. This is the only dependency that you need. Now, if you're a proper JavaScript developer, you're probably going to do something like the above. Or if you're like me, probably use script tags. Okay? So that's it. The important thing from this slide is that that's the only dependency that you need in order to do neural networks in JavaScript. Well, specifically in this case, in the browser. There's a couple of different things you can do with it. Okay? Quite a few different things you can do with it. You can train models. So everything I showed you before about that neural network, about creating different nodes, about creating weights, and about backpropagation, all that training mechanisms, that's available to you in, that's not a good example, code example, but that's available to you in TensorFlow JS in the browser. Okay? But the other really cool thing about it is that you can load pre-trained models. Load pre-trained models. So you can have models that have been created elsewhere, maybe on the Azure platform, you're creating some machine learning model. You can then export that, and in fact, they've got tools that you can use which can take a machine learning model creating using a bunch of different frameworks, convert them to be able to use inside TensorFlow JS, and you can load them up just with this line here. And if you want to find a bunch of them, you can find them in a repo called TFJS models. And the one, second time, it's going to get me, isn't it? The one important one here is MobileNet. Okay, so MobileNet is just a model. Okay, it's a machine learned model, a static model you can load, and it's been trained up to recognize about 1,000 things in the world, just 1,000. But it's still pretty good, right? And so this is all the code that you need inside your browser, well, apart from the import. Actually, no, you don't even need to import TensorFlow. This is it. You just get an image, load the MobileNet. It's quite a large load, right? And then you can just do model.classify with the image, and you get the predictions. Okay? That's all that I was doing, or that's all that he was doing in that demo of his, right? But you saw the predictions weren't that great. They were okay-ish, and you actually use MobileNet for a number of other things, something called transfer learning as well, for which it's probably more useful. But the actual predictions initially are not that great. Any guesses? Come on, people, you must know by now. Azure, here we go. Oh, there she is again. Really confused. So computer vision, we have a computer vision API. It's extremely rich, extremely rich. It does so much. And in fact, my colleague Sarah Drasner wrote another demo that we put on AI.js Rocks called the what should you call it? The dynamically generated alt text. So the idea for her demo was, can you increase accessibility for websites by automatically generating the alt text for images for visually impaired people, so it describes the image? Because one thing our computer vision API does is it returns to you some text, some caption that's describing the image at the top. So I don't know if you can see this. I'm not going to try and zoom. But at the top there, it says, a black and white photo of Thomas Edison. The text says, hey girl, did we just share electrons because, oh, I don't even get that. But but that text at the top is generated by the computer vision API, just by looking at the picture. And there's two kind of important things you should see from this, I think are really useful. It knew that this was Thomas Edison. Not just a person, a male, Thomas Edison. So it knows about entities and people around the world. It can facially recognize people. And also extracted text as well from images as well, right? Now, although this is a lot better than MobileNet, it still has its problems as well. So there's a couple of people on Twitter when she released kind of found a couple of other things. So this says, a star-filled sky, the text says, I think it's an Asian language, I don't know, for something, so obviously that's incorrect, right? Has this one, which I'm not really sure. I mean, it technically could be. I mean, you don't know, do you? It could be stuffed animals. Probably isn't, but it could be stuffed animals. And the next one I like because I think we were half right. Okay, we're half right. So, okay, so it has like some problems, but it's pretty good. It's pretty good. It does a lot more than just telling you what's in an image, right? So, to summarize, one of the key things I want you to take away from this demo is just that TensorFlow JS. It doesn't have any dependencies. I think that's one of the takeaways. One of the only takeaways to take away from this demo is just TensorFlow JS, no dependencies. You can just drop a script tag in and start doing machine learning in the browser. That's what's so beautiful about it. MobileNet is a really simple way to analyze images. Honestly, it's not used for that. I wish I had time to go into demos where I do explain how we would use it, but I don't. But it is a simple way to analyze images. Oh, it's not the image API. Oops. Use the Azure Computer Vision API to get something a bit more accurate and powerful. Oh, got enough time. Fantastic. For my favorite demo, which is image to image. So this is created by a guy called, oh my God, I'm not going to get his name wrong, Aditya. He's actually from Yemen, studying in Saudi Arabia, and he's still studying. He's still at university, and he built this. So based on a paper called Pix to Pix, okay? So this is all running in the browser. So basically, he created this. Okay? So in the browser, you can draw an outline of a cat, and it'll create you a very accurate representation of a cat. Okay. So this is using an algorithm underneath called Pix to Pix, and the key thing here is actually running in the browser, is my point. It's using JavaScript, it's running in the browser, and actually underneath it's all built using TensorFlow JS, right? And what it is an example of something called a generative adversarial neural network, okay, GAN. Okay? GANs are pretty cool, really cool actually. And I thought I'd try and explain it. Please forgive me, because they're quite complicated. But GAN is really interesting because it's actually based upon two neural networks that are competing with each other, hence the word adversarial. Okay, they're competing with each other. So we have one which is called the generator, and the other one that's called the discriminator. Okay, the generator's job is to create images of cats. The discriminator's job is to figure out if an image is a real image of a real cat or a generated image of a fake cat. That's a discriminator's job, okay? So what he did, and there's many different types of GANs, right? But while he built his was he basically got a bunch of images of cats, got the outlines of the cats using some computer vision libraries to get the outlines, so like a sketch, right? And then you'd feed in that sketch, just the outline, into the generator. Again, it's just a neural network. You're feeding in perhaps the pixel values. It was initially had randomized weights, and this generator's responsibility was to create an output image, right? But because it's initially randomized, it's probably just going to create noise. This first image is probably just a picture of some noise, right? Then that gets fed to the discriminator. All of those images gets fed to the discriminator, plus all the images of real cats. Okay, and the discriminator's job is then to look at these images and then go label them fake or real. Okay? Again, the discriminator initially was just randomized with random variables for those biases. So it's not going to do a great job of discriminating. But what happens is if the discriminator is wrong, so let's say it said the real cat picture is fake and the fake cat picture is real, if the discriminator is wrong, then it calculates how wrong it is using some various algorithms and does that thing called backpropagation. Backpropagation is how you then tweak the biases of this neural network so next time around the discriminator gets better. And conversely, if it got it right here and the discriminator was wrong, the discriminator then goes, okay, you now need to backpropagate to get better at generating images. So what happens is you've got this generator that's kind of not very good at generating cat images, and you've got this discriminator that's not very good at figuring out if a cat image is a real cat image or not. And then over time, they're both getting better, and they're both competing with each other, and they're both getting better and both competing with each other, right? So they're improving, both of them are improving over time until eventually you get to a point where the generator is creating such good cat images that the discriminator can't really tell them apart anymore. Then maybe you can say that this run is over, right? And so then once that's done, what you do is you take the generator. You don't care about the discriminator anymore. You just want the generator, right? If you want to do this in the browser, you just want the generator. Export it, use those tools to convert it into a TensorFlow.js model, load up with TF.js load model, and then run in inference mode, and you can get it to, and then you can pass in new sketches, and now you see how it's basically trying to figure out how to generate a cat image. Oh, that is gonna get me. If you don't see it, there's a little bar here. I've tripped over it 3 times now. That's how it's generating these beautiful, beautiful cat images that I'm generating there. Okay. What's the point? What's the point of this? Generating cat images? Is that the point of this? No. The point of this is probably a lot scarier than this. So this is another algorithm called, it's like pix to pix, but vid to vid. And as you can see here, it's generating videos. So the items on the left is the inputs, and what looks like real videos here are the outputs, right? So generating the outputs. That's computer generated. There's this one here, which is slightly more interesting. So with a given input, you can actually generate 3 different types of faces. Okay. There's this one here, where you can actually do what's called segmentation. So you're not inputting on a sketch, but on kind of like a segmentation, so kind of a colored chart is the input, right? And then what you can do is you can train it on your body, and then basically do fake dancing. Okay, so she's not dancing. It just took some pictures of her body, and then that image is generated from that, right? So if you pass in a new version of this, you can make her dance however you want her to dance, right? That's all fake. There's this one as well. Again, it's a segmented image of a car scene. This is using the pix-to-pix algorithm. This is using the vid-to-vid. I actually can't remember which one this is. And that's it. So this is generated. Okay? If you actually, you probably can't see from over there. There are some artifacts, so you can still tell. There's like a blob coming out of the car with no legs over there, and there's a few little weird things happening. But it's pretty good. It's pretty good. Yeah? This isn't running in the browser in JavaScript yet. Okay, but the world's moving pretty fast, right? Gets even weirder. How about this one? The input doesn't have to be an image. You can train it with text. So what's happening here is the GAN has been passed in, this bird is white, black, and brown in color with a brown beak, and it's generated the image based off of the textual description. Okay? Above, this flower has long, thin yellow petals and a lot of yellow anthers in the center. It's generated the image. How far away do you think we are from saying, put a form with 3 input fields, one of them should be a date field, and have a submit button at the bottom? I don't think too far. So, just to summarize, so GANs are really interesting. GANs are very, very interesting. They've only been around for 2 years now. GANs are really interesting, and are a great way to, GANs learn to generate kind of new data, okay? They're generative. They actually take a huge amount of compute to train, so they're not being trained using JavaScript. In fact, they take far more compute to train than a traditional neural network, right? But the generator model, if you optimize it enough, as the cat one, can actually be exported so it can run in the browser, right? So we can see some interesting use cases there for us. Just kind of a few thoughts for me in general before I finish off. So, because one question I've been asking myself for a while now is, where does JavaScript fit in this kind of AI machine learning Java landscape, right? It's kind of a question I've been asking myself about a year now, which is like, where do we fit in? What's happening in this space? Are we just going to be ignored and taken over, and Other people are going to take over. Like, what's going to happen, right? And I see a future, actually, where there's a specialist machine learning JavaScript role, okay? A machine learning JavaScript engineer. When we started the meetup group in London, AI JavaScript London, we expected only JavaScript people would turn up, because we were JavaScript people. But something really weird happened. Half of the people who turn up to our meetup groups are machine learning engineers, data scientists who want to learn JavaScript, okay? Because they are really, really good at building models, but they're not very good at then taking those models and then building an application out of them and then doing something with it. That's what we're really good at, okay? So I see there's a role in the future where you're going to need to know enough about AI and enough about machine learning in order to take these models and run with it, right? Maybe you don't need to sit there and read papers all day, unless you like to. I don't. And so final few thoughts. If you are interested in learning a little bit more how to build some application like this, especially using Azure, I have has anyone heard of the MS Learn announcement, Ignite? Okay, so we've created a whole new learning platform. It's gamified, you earn badges, you earn points. It's all done in the browser. It's fantastic. I feel very proud that the Mojifier, the project I called the Mojifier lives, because they allowed me to recreate the Mojifier as a Slack bot, and now you can learn how to create it, and you're going to get 1,800 experience points if you follow this module. It's going to be available on the MS Learn platform. It's not quite there yet. I was up till 1 in the morning last night with the MS Learn PMs trying to get it in. Didn't make it, but it should be there later on this afternoon, so if you follow that link, it should take you to the MS Learn module to find out more. And final thing, if you are interested for any other sessions today, I do recommend these two. The top one is my boss, John Papa. So if you don't know John Papa, he's pretty big in the Angular web development space. So he's doing a really interesting talk on full stack Node.js applications with VS Code. And who here uses VS Code? Wow, everybody. Who here knows Brian Clark? Okay, he's the guy who makes the monthly VS Code videos on Twitter that you see floating around. He's also my colleague, and he's got an amazing session today at 2 p.m. where he's going to go through a whole bunch of VS Code tips and tricks. If you're using VS Code, highly recommend you go to it. It changes so fast, you're going to need to know all these tips and tricks. Well, thank you very much for your time, and if you want to follow me on Twitter, I'm Joik.